So we're going to look at some MRIs for fun. Next slide. So here's your femur and your tibia here. And then when this, and MRIs, MRI picks up detects liquid. What it does is it flips the hydrogen ion in water, or hydrogen ions in anything, but especially in water, it flips them back and forth. And so you put a magnet on it, it flips the hydrogen one way, and then you release the magnet and it flips back and it releases a little bit of energy. When it does that, and you detect that energy, if there's a lot of water, you'll have a higher signal. So the signal will be white. If there's not much water, then it'll be dark. So here's your intact area of meniscus. Remember I told you to remember there's like little triangles. So here they are. There's the two triangles. So posterior and anterior meniscus. I'm not sure which knee this is, but in any case, so there's a sagittal section through it, through the knee, showing the two anterior and posterior meniscus. That's normal. That's what it looks like, nice and dark. Maybe a tiny little bit of whitish part where the arrow is pointing, that big arrow is pointing. Next slide. Now we have a lot more white in here, and you start seeing a little bit of tear in that meniscus right there. So you start seeing some white, and that would be indicative of liquid that's in and around, instead of it just being that fibrocartilage that composes the meniscus. It's going to have some liquid in there. Next slide. Here's another example of tear. So you see this white line in the meniscus. And here's another. You have this red arrow there, and you have it's a simple tear going across the horizontal tear going across the meniscus there. Next slide. So then you also have knee dislocations. Other things that cause damage to the knee. So dislocation means it's not in the location it's supposed to be. It's dis, meaning out of where it's supposed to be located. So you have a dislocation. So on the left side is normal knee. On the right side, you've had some hit from probably on the tibia and fibula, knocking it medially and leaving the femur, and the person didn't hit, it might be a football injury, so somebody hit here and knocked this the tibia and fibula medially, leaving tearing all these ligaments. So you tore the anterior cruciate ligament, and also looks like the PCL as well. Leaves the lateral collateral ligament intact, but it tore the MCL and may have torn the meniscus as too. If this happens, a lot of times the meniscus will be torn as well. Next slide. So here's an example. So you have force of impact right at the knee. The condyle of the femur slams down into the lateral meniscus, tearing it. You also get a tear of the anterior cruciate ligament. You get a tear of the tibial or medial collateral ligament. So this is called the unhappy triad. The PCL is pretty thick, and a lot of times it doesn't get torn, but you'll end up with tears in the meniscus and the ACL and the MCL. Next slide. So here's some photographs from the lecture text. I took this out of the textbook. An MRI of a torn tibial or MCL, tibial collateral ligament or medial collateral ligament, and what you see is it's kind of like this. Instead of being straight, that would be normal. So there's a little bit of curvature, waviness to it. So that shows you that it's torn and doesn't have its normal shape. And here's your part of the meniscus there. It's a little triangle there. Then you have a torn ACL. It's hard to see in this picture. And anytime you do MRIs, you're never going to look at just a single picture. You're always going to look at a series of images and go back and forth through them, so that you know what you're looking at. So you look up and down through the image, and you can see, you can interpret a lot better what you're looking at. If you look at a single image, it's always hard to interpret what you're seeing. In this case, this is a torn ACL. So the ACL should come down here, but it doesn't. It seems to be retracted back at this point. So, oops, I'm sorry. That's not correct. I'm looking at the wrong view here. So it should be coming down like this way, but it's actually flipped up here. So that's what all this is. So you got a big tear of the stuff. Next slide. Okay, we're talking about arthritis as well, because since we're here talking about joints, it's really important to understand that stuff. So arthritis and osteoarthritis. So what are the differences in rheumatoid and osteoarthritis? So rheumatoid arthritis is, so here's a femur and the tibia and fibula on the left. So this is a regular knee joint over here. What happens in rheumatoid arthritis is that you get inflammation occurs, and the synovium, where the synovial fluid is made, those synoviocytes, they start growing and dividing, and so you start getting more and more synoviocytes, and they get thicker, and they start making more stuff, and you start getting more and more of a lining underneath that. The alveolar lining starts getting thicker under here, and then you start getting this is a blood vessel. This is a blood vessel here. So that's blood vessel. So this synovium, this starts getting inflamed. Then as we go on, next slide, you start getting lots of, instead of this being just these synoviocytes like this is normal. So you get lots of them on this side, and then I'll get all this called angiogenesis, which is blood vessel formation, and lots of inflammatory cells, and you get what's called a pannus, which is a swelling that's on the side of the joint. And so this joint, you can see this big bulge here on the side of the joint. Next slide. So here are the stages. So you start getting a little bit of, so this one's okay. You have a little synovitis, so you have a little bit of inflammation, swollen joint capsule, not as much synovial fluid, thickened synovial membrane, and the tendons, sheath gets inflamed a little bit as well. Then you get, number 3, you get what's called a pannus formation. So the whole area is inflamed and sore. You have a pannus formation, which is it's infiltration of blood vessels and also just extra cells and junk in there. Bone and cartilage starts being eroded. Tendon sheath starts being inflamed. Then what you get a fibrous ankylosis. That's what this is called, what those words mean. It means that you get this fibrous connective tissue fills in the space where the pannus was. Inflammation goes away, okay, but all you have is fibrous connective tissue, and the joint, instead of have this nice space here, now is all filled in with fibrous connective tissue, and so the joint becomes immobile, and then then it eventually will turn to bone and actually ossify, and so there's no articular cartilage. These bones fuse, and this is advanced rheumatoid arthritis, and you also start getting osteoporosis in there as well. So not much inflammation, but the bones are now fused, and they can't move. So you lost movement at that joint. Next slide. So here's another view of normal pannus formation, and then advanced degradation of the joint, and a formation of a fibrous ankylosis. Ankylosis means an area that's where basically means it used to be a joint, and now the bones are essentially fused with this fibrous connective tissue. Next slide. Here's a view of osteoarthritis, which is different from rheumatoid arthritis. What you get in osteoarthritis is you get degradation of the bone and cartilage, and so you start getting cartilage fragments as well as bone fragments in osteoarthritis. And then when it's advanced, you get what are called osteophytes. There, you start seeing those, and these are osteophyte, is that little guy there, and you can see those And here's some more up here. These little edges, and there's another one there. And those little edges that form off the bone. And you can see those in X-rays. So there's degradation of the cartilage, degradation of the bone. You start getting, and you have loss of cartilage, loss of bone, and you have a loss of joint space as well. So you should have this nice regular space across here, and you'll have irregular amounts of space in osteoarthritis. Next slide. Here's the example of that. So osteoarthritis, you have normal. This is normal here, and then an osteoarthritis. Arthritis. Over there, you have loss of joint space, and you see those bones are just slamming against each other. Next slide. Another example of loss of joint space you can see on the left is normal. So normal joint space, and then loss of joint space there. Next slide. Here you have obvious loss of joint space there in this osteoarthritis in the knee. Next slide. And over here, well, just to point out, you still have a decent amount of joint space over here. But on this side, you've lost all that joint space. Next slide. Here's a picture. You can see the osteophytes a little bit here. Here's the osteophytes here, and you see a little tiny where the arrows point. There's also loss of cartilage, as well as there's just not much joint space in there anymore. Next slide. And these are also called bone spurs. So here's a normal knee on the left here, normal space there, here, fairly normal space, but this side is not good. And there's little bone spurs here and there called osteophytes. So narrow joint space and osteophytes there. Next slide. Just another example of osteoarthritis, left knee, loss of cartilage, meniscus, and development of some bone spurs as well. So you can see how the two bones are right next to each other. Next slide. And then you're looking at severe osteoarthritis, and you have deformity of the actual joint, of the actual bones now. And actually you have what's called subluxation of the knee, which means the bones are not in the normal position that they're usually supposed to be in. Next slide. Here's elbow, osteoarthritis in the elbow, and you can see there's just a lack of joint space in there as well. Next slide. Here's osteoarthritis in the acetabular femoral joint, and you have on the left side is normal, on the right side is narrowed spacing inside the acetabulum. Next slide. So your osteoarthritis in the foot between the proximal phalange and the middle phalange, or not, I guess that's the metatarsal and the proximal phalange. So you see how it looks there's all nice space all on these. These all look really pretty. And then you go over here and there's all kinds of junk going on there. So in X-ray, it's very obvious there's something wrong with that joint. Next slide.